Ridgey Academy is a Denver public charter school under contract with the Colorado Department of Youth Corrections. Home of the Rams, Respect, Attitude, Motivation, and Spirit, RVA is a 500-bed facility. RVA began in association with FIRST Robotics in 2004 for inspiration and recognition of science and technology. This organization brings together high school students for an intense competition that includes a 6-week build period where the teams design, engineer, and manufacture their robot. Each year the competition is designed around a specific type of challenge. In 2004, teams had to build a bot that could stack or move small tetrahedrons onto larger field tetrahedrons. In 2005, the competition named Aim High, teams had to shoot or dump 7-inch Nerf balls into a backboard 13 foot tall, or they could score into a low goal. Beginning in November and December, teams need to start thinking about the January kickoff date when they receive their kit of parts, and then find out what the task for that year is going to be. Now, considering I teach applied technology, integrating a technology lesson plan into the curriculum is almost humorous. One of the challenges each year for the robotics team has been to get some of the students involved with using AutoCAD, which is available to teams for free. Unfortunately, we've never been able to offer this as a formal course, and in the past 2 years, we really have not been able to take advantage of this technology. So, I thought, wouldn't it be nice if we could take our team design meetings and add to the design process from this into something more like this. Perhaps a little more realistically like this, where the students can work on the computers, adding to what they do on the chalkboard drawings. Because these guys wanted to do better and add to the legacy from the last 2 years' robots, we thought it would be a good idea to try to get something going on the computer. When I saw the LEGO Digital Designer earlier this year, I thought, hey, wait a minute, this might actually be fun. So off to creating the lesson plan and checking to make sure this would work. I first loaded the software on my own computer in order to familiarize myself with the software. Next, I checked system requirements to make sure it would run on my student machines. Our machines had 700 Celeron processors, so the 450 megahertz minimum should have worked okay. The 16 megabyte graphics card was built on board on the student machines, and we had a minimum of 128 or 256 megs of RAM with ample hard drive space, so it should not have been an issue. Then I loaded the software onto the classroom computers, and I reloaded it again and again and again. And this error message kept popping up, stopping the software from loading, to which I responded, uh-oh. So after a few days of pulling out my hair, which I really didn't have a lot to work with, I figured out that even though the Celeron processors with 128 megs of RAM did meet the requirements, the 8 megabyte VRAM did not. So I went into BIOS and reallocated it to 32 megabytes of VRAM. And it took the software almost 15 minutes to load, but at least it loaded this time. Surely this will work now, I thought, and it sort of did. Once the software loaded, it did actually function, but it was like sap drain from a Vermont maple tree. And as you can see, it did seem to have a bit of a funny effect on some of my students. I created an evaluation sheet for the students to use and turned them loose with the following instructions. Open the software and go to work. Let me know what you think by writing down on this worksheet your ideas and your thoughts. And then when you're done, you're going to sit down and lead a discussion with your classmates to show them how the software functioned on the computers and how intuitive or not it was for you to use. 3 students were able to spend one lesson, about an hour, using the software and concluded that moving the pieces in and out of the design plane was fairly easy. Overall, the software was not too difficult to master. And it was cool, and much cooler, to build Legos instead of editing Word documents and spreadsheets. The students really did enjoy working on this, as evidenced by those smiles. So, pretty much all the students had the same question. When do we get to use CAD to build next year's robot? And I responded with, when I get new computers.